Today is 18th November and we will continue from the last day. We have discussed ultrasonic welding. Today we will start spin welding. This technique is used for welding of plastics. Spin welding is similar to the friction welding process. So we can write similar with F or W. Here what happened, there were two cylindrical workpieces. They faced together and one was rotating and this is fixed. So because of this motion in the face of these two sides, there is friction. Because of the friction, the heat generated on these two surfaces, two mating surfaces, and because of this frictional heat, these edges get fused, and after a certain quantity of rotating cycle, these when these ends are get fused, then the rotation stops and the rotating side which is moving is pressed against the static one. So now the rotation stops and the pressure remains fixed and kept for a while, and in this time when the pressure was created on this job and hold it face to face with the other job, then the solidification occurs and cross-linking of the molecules at the face occurs, and because of that cross-linking the joint occurs. So this is very similar with friction welding. One object is kept fixed, other object was rotated, and then rotation stops when the frictional heat generated is able to fuse the material at the face. Then the rotation stops and it get pressed onto the other object, static object, and the pressure kept fixed for a while until the cross-linking of the molecules at the face, at the fused face occurs, and on solidification the joint is produced and then the pressure is taken away. Now in this case the both of the objects might be cylindrical pipe type or solid, or it might be one side might be of circular and other one might be cylindrical. So this type of joint can also be done. So at least one side or part of the joint should be a rotating type, otherwise the joint will not occur. Suppose you want two cubes to join face to face, you cannot do that because two cubes, each of them are not rotatable. But if you want to join two cylinders, then both cylinders are rotatable and you can join them. If you have a cube shape or a flat surface and that have to be joined with a cylindrical surface, you can join in this way. So one end or one part of the job should be capable of rotating. So is the working principle clear? If yeah, yes, okay. Then we go for the advantages of spin welding. Advantages are: number one, reproducibility. If joint is somehow wrong or does not require, then you cut it off and you can join the rest of the part with other material. Suppose this joint has been done and not necessary, then you can cut from here and you can take this and join the rest of the portion with a other surface. So that's why we can have that reproducibility of this type of joints. In this type, large parts may be joined. Number 3, the quality is high, so we can produce high quality joint. Number 4, here much quantity of fusion is not seen, so oxidizing cases are very less. So oxidizing polymers, those upon heating get oxidized, so those oxidizing polymers also may be welded. Okay, now we will discuss about the disadvantages. We'll talk about disadvantages. The problem is at least one part that to be welded should have a circular symmetry, and minimum rigidity is required, because while you are rotating it and while you are pressing it with an axial force, then if proper rigidity is not there, then the joint will not be straight and the joint will not also formed. So the setup should be sufficient rigid. Okay, our next topic will be vibration welding. In vibration welding, the two workpieces are vibrated at certain frequency and amplitude. These
হ্যালো
parts,
স্যার।
হ্যাঁ বলো।
স্যার, তাহলে স্যার স্পিন ওয়েল্ডিং এর সঙ্গে স্যার ফ্রিকশন ওয়েল্ডিং এর স্যার ডিফারেন্সটা কোথায় থাকলো?
ডিফারেন্স তেমন কিছু নেই, প্রসিডিওরটা সিমিলার, কিন্তু যেটা তোমার ফ্রিকশন ওয়েল্ডিং ছিল সেটাতে দুটোতেই সিলিন্ড্রিক্যাল জব হতেই হতো, আর যেরকম ধরো ওই যে হুইল হাবগুলো ছিল, যে অ্যাক্সেলগুলো বানানো হচ্ছিল, সব কটাই মোটামুটি সিলিন্ড্রিক্যাল ছিল। ব্যাপারটা সিমিলারই, কিন্তু ডিফারেন্সটা হচ্ছে যে ফোর্সটা দরকার হচ্ছে বা যে রোটেশনটা দরকার হচ্ছে সেখানে। মানে যেরকম ধরো একটা মেটালকে তুমি যদি ফ্রিকশন ওয়েল্ড করতে চাও, ইফ ইউ ওয়ান্ট টু জয়েন টু ডিফারেন্ট ম্যাটেরিয়াল বাই ফ্রিকশন ওয়েল্ডিং, so in such case you require a very high rpm and also require very high axial load. The machine will be very very rigid and very very big also, that should capable of uh, rotating a very heavy workpiece. So the machine is basically the heavy and rigid, but in case of spin welding, your machine can be, compared to FRW machine, very less rigid and less power consumption will take place and lesser in size. So it is basically a lower capacity machine.
ওকে স্যার, থ্যাংক ইউ স্যার।
But the working principle is quite same. Okay, then we are discussing the vibration welding. In vibration welding, two parts are vibrated with certain frequency and amplitude. This frequency and amplitude depends on the skill of the labor and the types of material and the shape of the material. Now, these parts actually rubs, RUBB. Actually, they get a rubbing effect. So they get rub each other under a pressure, causing a friction between their surfaces, which generates heat, and this heat results in melting polymer in joint region. The workpieces are fused together, and after a predetermined time the vibration stops. The polymer molecules are cross-linked when the workpieces cool down, forming a straight joint. So when vibration stops, the molecules get cross-linked when the workpieces cool down, thus forming a strong joint. This process is similar with uh, ultrasonic welding, but there are some difference. There are some very important differences. In case of ultrasonic welding, the jobs are kept fixed and the tool vibrates on a particular frequency on a particular point. But in case of vibration welding, the job fluctuates. I mean, the job get the vibration with the vibrationing tool or the horn or the sonotrode, and the frequency is very less here. So we'll write the frequency of vibration welding are 100 to 500 Hz only. Whether this 100 to 240 Hz is a common range. So in case of ultrasonic welding, the frequency was 20,000 Hz to 70,000 Hz. So there is a large variation. Now, in case of this vibration welding, the job is fixed with the tool, and when the tool vibrates, the job also vibrates. As a result, in these two surfaces, a rubbing option, a rubbing action get created. Because of this rubbing, the frictional heat generated and melts the material. And after a predetermined circle, when the skill of the lever is sufficient, the lever will know that after 5,000 cycle or after 2,000 cycle or after 500 cycle, the object surfaces will get melt, and he stops the vibrating and keep pressure on these two parts, and after solidification for a particular amount of time, they are pressed with one against other, and after the solidification of the material, the joint occurs. So there are different type of polymers. Polymers are like, if you can remember from your second year, there are subject which is material engineering or material science or engineering materials. You have probably learned the polymers are different type, including amorphous, semi-crystalline, and crystalline. So they produce various fabrication methods like uh, thermoforming, extrusion,
Sir,
injection,
what are these thermoforming extrusion?
injection molding, blow molding, compression molding, transfer molding, the product of all these combinations of manufacturing processes are many processes can be welded by vibration welding. So there are three types of crystals, and with these three types of crystals we can uh, manufacture different parts by in different methods like thermoforming, extrusion, and injection welding, blow molding, uh, compression welding, compression molding, transfer molding. These processes produces different parts, and those parts can be again further joined by this vibration welding method. Now this thermoforming, these you have to you have already learned from primary manufacturing processes. However, I will give you a recap. Thermoforming means you heat up a material, a plastic material, a polymer material that becomes liquid, and then you pour it on a die and it get shape and get the form of that particular die. That is called thermoforming. Extrusion means you you can make up uh, wires from bigger cross section to smaller cross section, but you can elongate the length of it. Now there are different method of extrusion like forward extrusion, backward extrusion. Can you remember? There is a die and there was a hole through which the material can come out, and with another side of the die a piston or a ram is pressed on the semi-liquid material, and from the front the particular shaped or wire shaped material comes out as a constant process, and plastics also made in this process. Injection molding is the material is injected with very high pressure by very high pressure in a mold. In blow molding, a very small uh, quantity of material or plastic is or a rubber is made, and that is uh, that faces a pressure of blown air with very high pressure, and as a result this balloon type shape of rubber or plastics get you know mm, get pumped up and takes the place of the take the form of the die, like the plastic containers, uh, toys, lampshades are made in this blow molding technique. So a very small quantity of uh, balloon type shape of rubber or a plastic or a polymer is taken, and between that air is blown, and in outer side of that balloon there is a particular shape, a die is produced, and suppose you have a container and within it you have placed a balloon, then you are entering air into that balloon. So what will happen? The balloon will get elongate, the volume will rise, and the balloon will finally take place as its outer side is fixed by a die, so the balloon will take place of a die. Now on solidification, the polymer will get a fixed a type of uh, shape. So all the plastic bottles, water bottles, one-time use bottles, PET bottles, or different plastic containers where we put our spices, biscuits, all those things are made by this method. Even some glass containers also made by this method. So you just put up any processes and put up in YouTube, you will get the video. It is very easy. Now the compression molding is to put material and compress them so that the outer side takes the perfect shape of the mold is compression molding. Just like the small ওই যে লক্ষ্মী ঠাকুরের মূর্তি, গণেশ ঠাকুরের মূর্তি বানায় দেখেছো ছোট ছোট, those are made by the mud pressed against a die. Toys can be also made any okay, there is transfer molding. The material is transferred into a mold and then wait for solidification. That is the transfer molding. Now these are basically similar methods. Molding means there is a mold and material is provided there by means of blow, by means of transferring, by means of compression, okay, by means of other force or pressure created by a ram. So in different methods we introduce material inside a mold and give the shape of that mold. Now these products of these different shapes, of these different methods, can be again vibration welded. And vibration welding is used in automotive, and domestic appliance industries. Now advantages of this vibration welding are oxidizing polymers may be welded. This can be easily automated. In all the industries this method is of course automated, otherwise it will take huge time. High productivity, large and complex parts can be welded. Now we discuss about the disadvantages of vibration welding. That is relatively expensive equipment required and minimum rigidity of the machine is required. Okay, so these are the major methods of welding plastics. Now, with this, we have ended our module 1 and module 2. Now, we will start with module 4. In module 4 portion, the welding defects, types, causes, inspection, remedial measures is to be taken by your SK sir, and we will advance on the next topic, that is the testing of welding joints by visual inspection, dye penetration test, and ultrasonic and radiography. So let us start.
Sir, what was the last line, sir?
Last line, testing of welded joints by visual inspection, dye penetration test, ultrasonic and radiography.
No, sir, no, sir.
Then?
আপনি যেটা লিখেছিলেন খাতায়।
আচ্ছা, minimum rigidity required.
Okay, sir. Okay, sir.
Because the machine will be vibrated. Okay, so now when we discuss about test, we have to learn how many types of tests are available. Testing and inspection are two different things. Don't mix them up. Testing specially refers to the physical performance of the operations to find out quantitative measure of certain properties, such as mechanical, physical, any type of property. Okay, so with testing, we will measure some physical property of the product. That property may be like mechanical property, might be physical property, and we will take a quantitative measure. Okay, for example, if we discuss about conductivity, that is a physical property. Like temperature, that is a physical property. Volume, that is a physical property. Pressure, that is a physical property. But when you talk about hardness or fatigue strength or tensile strength, compressive strength, bending strength, these are all mechanical properties. So when you measure all these properties, that will be called a testing or a test. Okay, and there is another term which is called inspection. Inspection refers to just examine visually or by some instrument of a welding structure or a product. Okay, so inspection may be qualitative, but it is not quantitative, it is qualitative and involves only visual observation of the correctness of functioning or dimensions. মানে আমরা ডাইমেনশন গুলোকে চেক করব অথবা ফাংশনিংটাকে চেক করব যে কাজ করছে কি কাজ করছে ওয়ার্কিং অর নট ওয়ার্কিং. So these are called inspection. So in inspection, what we go for its dimension and its working capability, whether it's working or not. That is called inspection, and which in most of the cases will be done by visually or with some measuring instruments. But the test is all the tests are done with different equipments. Now we talk about testing. The testing are two types: destructive testing, non-destructive testing. So in case of destructive testing, we get an idea if the work is given on a working condition, then what exactly going to happen. We get a clear idea on destructive testing. So it gives a better result, but it associates cost because the product we use for testing get broken or it gets obsolete, so that there is a financial loss there. So for bigger or costly products, we cannot go for a destructive testing. But destructive testing gives us a better, understanding. Or there are different type of destructive testing available, like tensile test, like compressive test, bending test, um, impact test, hardness test. And there are a lot of tests available. You just get the idea. The product will get damaged. That's it. And in non-destructive testing, there are radiographic test. This includes X-ray, gamma ray, etc. There is ultrasonic test. There is dye penetration test. There are several tests available in this way also, like magnetic particle test, eddy current test. Okay, I'll just write out the name. So there are lots of
Sir,
tests
what is
available.
MPT? Can you please repeat?
Magnetic particle test. So there are differences between these two testing methods. That is very, very important. You can write down the comparison. Important question is comparison between Dt and Ndt tests. Okay, so destructive tests are of course reliable and direct. Non-destructive tests are in indirect form and reliability to be verified. It is not accurate. In destructive test, the measurements are usually quantitative. We can find out the value of any type of strength. And in non-destructive tests, the measurements are usually qualitative. Whether it is okay or not, pure or not, whether there is any inclusions or not, like this. Is there any internal cracks or not? Just the qualitative measurement can be found out. In destructive test, the preparation of the test specimen is costly. In non-destructive test, the preparation of the test piece is not so costly. The direct correlation between the test measurement and the material properties that can be achieved, and in non-destructive test, you require skill and you require experience to interpret the result with the actual condition. So destructive test will require a very high time because we have to wait until the object is destructed. In case of non-destructive test, it is fast. On 100% material, the destructive test cannot be applied. So in such case, we have to go for sample test. And in non-destructive test, we can check all the samples. And as because we are checking one sample against a large lot of material, so there might be some faults in the destructive test result, because with checking one piece in a 1,000 piece lot, of course you can understand that the result will not be similar for all these cases. And in non-destructive test, all those 1,000 parts can be checked individually. So you just remember this question, comparison between destructive test and non-destructive test. Okay, and with their examples that are very, very important. Now you know the tensile test because you have learned it in second year applied mechanics laboratory. Bend test, hardness test. Hardness test is a different type like Rockwell, Brinell, Vickers. There are impact tests like Charpy and IJOD. And in non-destructive testing, you have done dye penetration test, magnetic particle test, dye penetration. Can you remember dye penetration?
Yes, sir.
First, you use a cleaner to clean the surface. That cleaner was SKC1 type cleaner. So with the help of this cleaner, we clean the surface thoroughly. Then we rub a clean cloth to soak if there is any cleaner left on the surface. Then we apply a dye, fluorescent color dye or a liquid, and we color the surface. Then we wipe after cleaner. Then after dyeing, after applying the color, we again wipe. So the extra color which is on the surface is wiped out. Now the colors are inserted if there is any surface cracks. Now then we apply developer. Developer are heavier. So developer, because of the cavitation method, goes deep inside the crack, and the dyes or the fluorescent color inside that crack will rise of the above because of its less weight. It is lighter than the developer. So that's why the dye pops up due to less weight. So now if after applying developer, if any fluorescent color is seen on the surface, that means there is a crack. Now first, when we do weld somewhere, first job is to check visually. So when the welding is done, the welding is checked by the welder himself, and as well as there is a checking person who checks the quality of the welds. After chipping, with chipping hammer, the quality is visually inspected, and if there is any cracks found, then it again gets repaired, or otherwise it gets selected. So the primary and the most fastest method of inspection is the visual inspection. Okay, visual inspection is done on each of the job, and it is mandatory for any type of cases. This is the fast method and the most important method. Now if it passes the visual inspection, then it either goes for dye penetration method, or goes for ultrasonic method, or goes for radiographic method. Now in this ultrasonic method, these ultrasonic wavelengths of 20 range is 20,000 Hz to 25 lakh Hz. This up to this range. So this wavelength, these waves, ultrasonic waves, are passed through the object. So it seems like there may be one probe, there may be two different probes. So this is another probe, this is another probe. Okay, these are transmitting probes. And these are receiving crystal, which is just another probes also. This is a transmitting device, and the bottom they are receiving device. So if the job is like such, so ultrasonic waves this strikes here and received by this other one. If there is any defect, suppose here there is a defect, so this will strike on here and it goes like this. So checking on these two different waves, we can understand that there is a defect. So there are two type of probes are used. One is transmitting probe, another one is receiving probe. So what happens inside, there are some transducers are used. With help of these transducers, this electrical energy converts into mechanical energy and produces the waves, and these waves get reflected on the other side or from the defect and get reaching to the receiving crystal, and then it get processed by another transducer and it converts the mechanical signal into electrical signal and it provides us if there is any defect. So the wave look like this. If this is the transmitted pulse, this is the defect pulse, and this is the normal back echo. This is the defect and this is the transmitted pulse. Okay, so if you go there, that is distance. Now if you look at this pulse, this is the highest strength.
So what is that back echo?
Back echo, yes. This is the transmitted pulse, and this when this pulse is coming back from the defect, this amplitude is very less, and when a normal echo is coming back, then this back echo, which is normal back echo, which is little lesser than the transmitted pulse but almost similar, but the defect has very less amplitude. So looking at this type of figures, an experienced person will understand that there is a defect. So this is the ultrasonic testing. Here in this case there are two different probes are used. There are some other probes where there is only single probe also used. So this is a double probe. There are single probe systems are also available. And in radiographic inspections, the X-ray and gamma ray are used, and they passed through the job and they get the variation of reflected, not reflected, actually the X-ray and gamma ray passes through the job, and at the bottom there is a photographic plate placed, and that plate will be affected in different regions depending on the relative density of the metal or any inclusions or through the thickness variation. If the ray get different thicknesses, they will be absorbed in different quantity, and as a result at the bottom in these photographic rays we'll get different images, different differences. So looking at that, we can understand if there is thickness variation or if there is any inclusion or if there is any voids or cracks or porosities or inclusions that can be found out. Now this X-ray uses X-ray tube, and this gamma ray uses cobalt 60 isotopes, which leaves these gamma rays. These are radioactive and kept in a lead container, and a photographic film is required to get the result. Okay, so radiographic testing is also a non-destructive test. Remember, in X-ray we require X-ray tube and very high voltage. You know how to get X-ray because you have learned it in your school days. You can remember that. And gamma rays also you have learned in school days. camera is taken from cobalt 60. If you forget, you just Google it. And the images taken in the photographic plate, like X-ray, we all know what is a photographic plate is. So we look at the images that caught in the photographic plate, and we can understand, if we have enough skill, that we can understand whether there is any cracks or porosities or inclusions. Now there are some advantages that the permanent record as a proof is obtained in photographic plate, and the reference standards for defects are available. So if the defects are very less, then that can be working. If the defects is very high, then we cannot work with that workpiece, we have to reject it. The limitations are, this is slow and expensive process, trained operator, experienced operator required, harmful radiation generates, and costly equipments are required. So UV rays, ultraviolet rays are very harmful, and that are generated, which is very, very harmful for our eyes and our skins. It causes cancers, skin cancers. So these are the disadvantages of radiographic rays. Okay, so we'll stop here today, and in the next class we will take a viva. In the next two class we will take viva on this advanced welding. Please inform your friends to be present in the class.